Well, I thought I'd try something new. Inspired by BigClive.com, or Big Clive's videos rather, I thought I'd give it a try and disassemble something. And as luck would have it, I just came across this little LED thing here that is pretty similar to the ones that Big Clive recently disassembled. Like, give it a try here. As you can see, it's just a spinning RGB LED kind of thing. It connects to the mains power, so 240 volts. Yeah, let's poke inside. What I particularly like about this version here is that the dome on the outside rotates, and if you rotate it, you can see one way it makes the red and the green LED light up, the other way around it makes the blue one light up, and the blue one is bright as the daily sun. So let's unplug that thing. And yeah, interesting enough, the bottom here is just clipped on, and it originally came with two screws to mount it to either the wall or the ceiling. And while the dome has a security bit here, one of these tri-lobed kind of things, the bottom, the probably more dangerous part, has regular Phillips type screws. So let's start with those. Oh, as you can see, I came across this thing in Sweden. Was in a rather cheap bin. Okay, what do we have here? Probably power. Also, I learned the hard way that capacitors actually retain quite some charge. So the big one over here should be here. Okay, done. Yeah. I shall go into the circuit design in a little bit, just for reference. The big capacitor, bridge, what appears to be a bridge rectifier, and some diodes, some more capacitors, a resistor, and yeah, some discharge resistor as an SMD. Very strange indeed. Now let's try get the top part off here. I need to bring out the more advanced security bits here. I think this one should do the trick. Not perfect. Nope, this requires force. I'll be back momentarily. Okay, that took quite some excessive force, and I think I broke the mechanism in the process. Anyway, neatly labeled RG and B LEDs. Some very gruesome soldering, not cleaned at all, very dirty. Let's have a look at the LED part here. Another screw and another screw. Oh yeah, aluminium based PCB material. And yeah, what's left of the motor. Clearly I broke something. Peek. Also, I'm not the tidiest of all persons. What you can see here is just about the clean part of my desk. I shoved everything else out of the view. Okay. Let's see. Also, it's quite late in the evening. Ah, there we go. The motor. Yes. Aha. That's interesting. Power supply goes to the LED PCB and then back to the motor. Now that you're awake. Yeah, I had to pull out the axle here. So something is stuck. Yep, something is broken in there. The gears probably had better days. And trust me, I also had better days disassembling stuff. I blame the sniffles. Okay. I think that gear should have been on there. Yep. I think I stripped away that gear part here. That should be on here. Yep, most likely. But yeah, that's no longer going to turn. Needs some serious repair. Okay, the motor is geared, apparently. Quite a heavy reduction. Holy, that thing must be turning quite fast. And the other screwdrivers. Nope, still too big. Yeah, that should do the trick. Okay, let's see how that motor comes off. Nice. That could become useful. Now let's see that again in motion. Oh, and don't try this at home, kids. Whoa! That is quite the engine. And I'm not going to touch it once I turn it on. I'm going to use an insulated here. That thing is actually turning quite fast. But it still works. Anyway, I'm going to reverse engineer the circuit in here and be right back. That diode here must be a Zener diode, but what voltage I can't tell because it's soldered in, and I want to somewhat keep that thing alive, so I'm going to measure that thing. 9 volts. Up next, where is it? Where is it? We're going to have a look at the power that thing draws and at the power factor. So we have 2.5 watts, 3 watts-ish, a power factor of 0.06. Whoa. I had a look at the circuit and, well, interesting is kind of an understatement. I really like that the input circuitry, let's see if I can zoom in a little bit here. Wow, it actually works. Ignore my doodles up here. The input circuit is actually protected here. What at first glance looked like a capacitor turned out to be a varistor, sort of overvoltage protection here, with one-time fuse in here, in the white stylish shrink wrap here, heat shrink tube of course. And this blue thing here looked like a capacitor at first glance and turned out to be a whoops, this blue thing here turned out to be a voltage depending resistor, VDR, or a varistor. So if there's an overvoltage, the fuse will blow and the device will remain broken until you replace the fuse. So yeah, don't hook it up on the wrong voltage. Next in the circuit is this big capacitor for the capacitive dropper here, and it seems to be 3.5 microfarad or thereabouts, and rated at 400 volt apparently. It has a discharge resistor across it with 100 kilo ohms, which is this little one down here. Interestingly enough, it also would have had SMD pad in here for the discharge resistor, which is unpopulated here. After the capacitor, we have the rectifier bridge. The negative part goes straight through the negative output line here, the gray wire. And the positive one goes through a 3.3 ohm resistor, which is this big chunk here, and goes into a Zener diode, which delivers 9 volt of somewhat regulated voltage, which is the black thing in here. The output stabilizer capacitor is 220 microfarad, 35 volts, so also on the safe side. And it has an SMD discharge resistor, whoops, over here, SMD discharge resistor, which I could not quite measure in circuit. It has 104 written on it, which to my knowledge should be a 10 with 4 zeros, which means 100 kilo ohms, just like the other one. But whenever I measure resistance across it, it only turns out mega ohms. So something is not right here. Okay, the LED board, on the other hand, also quite interesting. Just this one here. It has the incoming gray and white wire from the power supply, minus and plus 9 volt-ish, and all the LEDs are in series, but the motor is tapped off between the blue and the red and green LED, which accounts for the effect that we had in the beginning. Had to do an edit here, the frame wasn't quite right. So if I turn the motor forward, plus will deliver positive voltage here across the blue LED, and the blue LED will light up. If I turn the motor the other way around, the negative motor terminal will deliver positive voltage, which means the blue LED will not light up, but the red and green here are conducting. The negative terminal on the LED board returns the voltage to the negative terminal of the power supply, and over the forward biased Zener diode back to the positive terminal and back to the motor. So this strange configuration here, which is probably because the motor requires maybe 2 or 3 volts DC, and we only have 9 volt DC for all the 3 LEDs. So they're using one of the LEDs, the blue one, as a voltage regulator for the motor, which is well, working, I guess. So yeah. Anyway, that's this little piece of equipment, and I wonder if I can put it back together again. But it does have a little egg shape, so it reminds me a bit of Disco Humpty Dumpty. Anyway, have a nice day.